Vanakkam to everyone. I am Revati Chinnathambi from Department of Physics at AGN Metric Higher Secondary School, Kanganapuram. Now I am going to discuss about the first law of refraction, second law of refraction, refraction of composite light, then scattering of light. Initially, I am going to discuss about the first law of refraction, that is the incident ray, the refracted ray and normal to the refracting surface all in the same plane. That means first I will draw the refracting medium. For that, this only interface between the two mediums, the upper part of this horizontal line I will consider the first medium, the lower part of this horizontal line consider the second medium. The refractive index of this first medium mu1 and the refractive index of the second medium mu2. At the same time, the velocity of light through this first medium c1 and the velocity of light through this second medium c2. Next I am going to draw the normal line between these two mediums. Then the light ray incident on this interface at B, then gets refracted through this second medium. Refracted through this second medium. Incident ray AB and refracted ray BC and angle of incident I and angle of refraction R. Once again I will remember the first law of refraction, that is the incident ray, the refracted ray and the normal to the refracting surface all lie in the same plane. Next one, the second law of refraction. The ratio of the sine angle of incidence, and the sine angle of refraction is equal to the ratio of the refractive indices of the two mediums. Already I told this, the refractive index of this first medium mu1 and the refractive index of the second medium mu2. From this consideration, we are going to define that second law of refraction, the ratio between sine angle of incidence and refraction means, that is sin I divided by sin R. This is equivalent to the refractive index of the second medium with respect to refractive index of the first medium. This is known as Snell's law. Second law of refraction, the ratio of the sine angle of incidence and sine angle of refraction is equal to the ratio of the refractive indices of two mediums, that is sin I divided by sin R is equal to mu2 divided by mu1. Refractive index is given an idea of how fast or how slow light travels in a medium. That is nothing but the refractive index of the medium will give information for us about the speed of light through that specified medium. The ratio of a speed of light in vacuum to the speed of light in a medium is defined as the refractive index mu of that medium. One more definition is there for refractive index, that is mu is equal to C by V. Suppose I will consider this is the vacuum and this one is material medium. Now the refractive index of the this medium will be defined as the ratio between the velocity of the first medium, that is C, to the velocity of this material medium B. That is nothing but mu is equal to C by V, where mu refractive index of the medium and C velocity of light in vacuum, that is constant. C is equal to 3 into 10 power 8 meter second power minus 1, and V is the velocity of light in that material medium. According to the refractive index of the medium, we can conclude the speed of the light through that medium. If the mu of the medium is high, the speed of light is low in that medium. That means refractive index, the value of refractive index mu is higher value, means definitely the velocity of light through that medium will be lower. At the same time, if the mu of the medium is low, then automatically the speed of light is high in that medium. That means the value of mu is lower value, then the velocity of light through that specified medium will be higher. When light travels from a denser medium into a rarer medium, the refracted ray is bent away from the normal, drawn to the interface. I think already you have idea about the interface between the two medium. This is interface between two medium. Suppose I will consider this is the denser medium and this one is the rarer medium. That means the first medium rarer medium and the second medium denser medium. Now I want to draw the normal line. What is our concept? When light travels from a denser medium into rarer medium, that is the important. You see here, the light will travel initially from this denser medium into rarer medium. Denser medium into rarer medium. Now this is the incident ray, that is AB is a incident ray and BC a refracted ray. Then what will happen? You see, when light travels from a denser medium into a rarer medium, the refracted ray bend away from the normal, drawn to the interface. This is the interface, this only normal line to the interface, then the refracted ray drawn away from the normal line. The refracted ray drawn away from the normal line. At the same time, when light travels from a rarer medium into a denser medium, the refracted ray is bent towards the normal, drawn to the interface. This is also one of the important concept of refraction. Here also I am going to consider two mediums. That is first one vacuum, that is a rarer medium, and the second one material medium, that is a denser medium. Then I will draw the normal line for interface between these two mediums. Now the incident ray passing through the rarer medium, then refracted ray towards the normal. This AB only incident ray and this BC only refracted ray. Incident ray entering in rarer medium means the refracted ray drawn very closer to the normal. This is normal line. This refracted ray very closer to the normal line.